Hi everyone, this is Mrs. Finney recording a lesson for 7th grade math at Red Wing High School. This lesson video is Math 7 concept number 3, solving using math and expressions to solve word problems and write phrases. So you can see here our learning goal for today. At the end of today's lesson, we want to be proficient in this task, this learning task, and to be proficient in today's lesson, we should be able to confidently say, I can translate word problems into math expressions and solve using decimals, fractions, and mixed numbers. All right, so let's take a look at some math problems in the real world. I encourage you to have a piece of paper and a pencil out so that you can be writing down and solving these problems along with me. The best way to learn math is to do math, and we do math by writing it down. And you can use a calculator to help you translate and convert from fraction to decimal or mixed numbers to decimals. But I encourage you to also practice those rote skills by doing that computation out on your paper. All right, let's look at an application problem. So my checking account had $101.25 in it at the start of this problem. At the start of the month. This month I spent $99.50 and I earned $52. What was my ending balance? So the first thing we need to recognize is that when I spend money, that's like subtracting money. Okay? So I'm going to subtract $99.50 from my original starting value. So I spend $99.50, and I want to know how much is left in my account after that. And the answer is not much, which will become a 10, and that'll become a 9. Oops, I have an error already, because 5 minus 0 is 5. Not 0, and 10 minus 9 is 1. So if I spend $99.50, I'm only going to have $1.75 left in my checking account. But fortunately, I also earned some money this month. I earned $52. And earning money means I'm adding it back into the account. And so I, at the end of the month, would have a final balance of $53.75. I better be a little more thrifty with my spending next month to try and gain back some of that money. Now, some of you might be thinking, why didn't you do the $99.50 and then minus the $52 first? We absolutely could have done that. With most of these problems, there's more than one way to solve, and that's okay. If you solve it a different way, that is all right, because we also could have said this. We could have said, I start with 101.25, okay, and I'm going to add the amount that I spent and gained during the course of the month. And so I spent $99.50, which is like having a negative 99.50, but I earned $52. And so we could rely back on our concept number 1 and concept number 2 skills and use the order of operations and put my spending and my saving in parentheses and simplify that first and then do my subtraction at the end. More than one way. Either way would work. What's key is that you understand which process you use to get there. Let's look at another example. I plan to make a rectangular garden that is 10 feet long by 6 feet wide. How many feet of lumber do I need total? So for this problem, I'm going to access my visual learning or my triangle style of math, and I'm going to draw a picture. So I know I want to draw and have a rectangular garden. Okay. And it's going to be 6 feet wide by 10 feet long. The first thing I notice and double check is that my units are the same. I'm in feet and feet, so I don't need to worry about checking units. They're already the same. Well, if one side of my rectangle is 6, the other side is also going to be 6. And if one length is 10, the other is going to be 10. Okay. How many feet of lumber do I need total? The word total, we know from our word walls activity that we did in class today, that the word total means we want to add up the numbers. And so I have 10 plus 10 plus 6 plus 6. You also could recognize that we have two widths and two lengths. And so you also could have used your perimeter formula, 2 times the width plus 2 times the length, and found your perimeter of the garden. This, of course, assumes that we measure twice and cut once and don't make any mistakes. We're going to buy exactly the amount of lumber we need and not have any extra or leftover. All right, let's look at setting up one more example here. So I have a recipe. My 5-year-olds love to bake. Their favorite is to bake cookies. Okay. And so I have a recipe here that calls for 3/4 cup of flour, but my 3/4 cup measuring cup is missing. It probably got smuggled out into the sandbox by a certain 5-year-old. And so I still need to measure my 3/4 cup of flour. How else could I measure 3/4 of a cup? So, yes, we could probably go borrow a 3/4 cup measuring cup from the neighbor, or we could think of a few other ways. If I have a 1/4, whoops, my pen isn't working. There we go. If I have a 1/4 cup measuring cup, I could use that 1/4 cup 3 times, and 1/4, 2/4, 3/4. Or I could say, well, I don't want to have to do that many scoops. I'm going to use my 1/2 cup measuring cup. And I know that 1/2 is the same as 2/4, because if I multiply the top and bottom by 2, I know that 1/2 is the same as 2/4, which means I could use my 1/2 measuring cup plus 1 scoop of my 1/4 measuring cup. So more than one way. The goal of this lesson is for us to start recognizing that there's more than one way to solve these problems. What's important is that you understand which method you used and are able to explain your process and your thinking to someone else. We have enough time in this video recording to do one more example. This one's for our athletes. I know there's lots of cross-country runners that are lucky enough to get to compete this fall. Football players and volleyball players have to wait till the spring, but our fall sports, some of them are up and running. So we've got some athletes. I run 1.5 miles every day. How many miles will I have run after 5 days? So we could use 2 different methods to solve this. The first would be to just keep track of each day. Now I'm going to convert 1 and 1/2 to 1.5. And so I have 1.5 plus 1.5 plus 1.5 plus 1.5. And I could add up my total distance, or I could also recognize that if I'm doing the exact same amount every single day, I could multiply by the number of days I run that distance. So we could use repeated addition, or we could use multiplication to solve this problem. You'll notice that some of these problems I've helped show how we would set them up, but I haven't solved and given you that final answer. I encourage you to pause the video and solve this problem. Try it both ways. Confirm that you get the same answer so that you can start to connect multiple methods to solving similar problems. I hope this helps you interpret word problems and turn them into math that you can easily process and complete. I will see you in our next lesson.